Good day everyone, we are from grade 11 STEM Fortitude.
Today, we're opening the doors to our laboratory to share our hands-on journey through the world of robotics, where we'll be diving into our experiences with servo motors, ultrasonic sensors, and I2C LCD. Our goal isn't just to show you the hardware, but the heart behind the process. We hope to inspire future STEM students by sharing the challenges we faced and the fulfillment we felt in overcoming them. So, come and join us!
In this video, you will see and understand how the components have worked together. In Robotics 2, we have worked with three main parts: servo motors, ultrasonic sensors, and I2C LCDs. We learned how servo motors move to exact spots, how ultrasonic sensors measure distance to avoid things, and how the I2C LCD shows numbers and data. In the future, we expect these components to work all together to make a small robot. We are looking forward to these components helping the robot interact with humans.
A servo motor moves to exact angles and stays there. In our experience, the servo motor didn't work immediately because the wiring is not right. We've got no idea what the purpose of the red, brown, orange wire does, so we did some research and that's when we learned about the servo motor and how it worked for us to have knowledge about it. The purpose of the red wire is to provide voltage, usually 5 volts, to power the servo. The brown wire connects to the ground GND to complete the circuit, and lastly, the orange wire carries the pulse width modulation PWM signals from a controller to determine the servo's position.
The ultrasonic sensor is used to measure distance by sending sound waves and receiving the echo. During our activity, we use it to detect objects and measure how far they were from the sensor. At first, we were confused about its purpose, not until we saw the interface display panel on the computer, where we could see the reading of the distance. After understanding this, we managed to properly configure and test the sensor. Through this activity, we learned that the ultrasonic sensor is important for obstacle detection and automation in robotics. The I2C LCD is a display used in robotics to show information like number sensor values, and it's easier to use because it's needed fewer wires. In our activity, we use it to display data from our system. But we had problem with wiring, which caused confusion and prevented the LCD from working properly. We solved this by carefully checking and fixing the connections. In the end, we finished the task successfully and learned that the I2C LCD is important because it provides feedback and help in monitoring and debugging the system.
System integration is combining different components into a single coordinated system. In this project, parking assistance system, the ultrasonic sensor, buzzer, and LEDs are connected through the microcontroller to perform a simple parking assistance system similar to what found in real vehicles. The ultrasonic sensor measures the distance, and when an object is near, the buzzer makes a sound and the LEDs lights up. Proper integration allows the components to communicate with one another, ensuring accurate data processing, correct responses, and clear output display.
We experienced several challenges, such as wiring issues where some components did not work due to incorrect wire inputs, which taught us to carefully follow the guide and ensure proper placement. Another challenge was coding, especially when installing the liquid crystal, which made the activity harder. We also encountered unexpected program behavior, like it crashes or gives the wrong results. From this, we learned that debugging involves identifying and fixing errors in the code, which can also be affected by desktop lag.
These cases improve our patient as we try to patiently understand the problems. When there's a problem, we always try until the problem are solved. We don't give up easily. By teamwork, we help in everything by looking out for each other whenever any one of us needs help.
Robotics isn't just about building machines, it's about building yourself. We have learned that technical skills like wiring and coding are only half the battle. The real growth happens in how we connect with our teammates and solve problems under pressure. To future students, my advice is to be patient and not get discouraged when problems occur. Remember that mistakes aren't failures, but are steps to improvement. Double check your wirings, Ask questions often or seek help from your classmates or teachers. And most importantly, enjoy the process and stay curious as robotics becomes more rewarding when you are willing to learn from challenges.
We hope that this video can help our aspiring students to look forward to robotics. Cause yes, it may seem hard at first, but when you learn the basics, it will be easy for you to do the given activities like we did.